Hi everyone, how are you today? I hope all of you in good condition right now. Alright, we continue our topic today. As you can see, it's about interaction of matter. Standard competence 3.4 explain concept mixture and pure substance, physical and chemical properties, physical and chemical changes in our daily life. If we place a drop of water on a piece of plastic surface that won't interact with water, the water will not wet the surface and it will retain a spherical shape. But if we place a droplet on glass that will interact with water, it will spread out and maximize interaction with that surface. How could that happen? In the previous lessons, we have learned about kinetic theory of matter, right? Kinetic theory of matter states that all matter is made of tiny particles that move. And also differences in the kinetic theory explain why matter exists in different states. Particles of matter are attracted to each other, so they tend to pull together. The force attraction between molecules of the same kind or within a substance we call cohesion force, and the force attraction between molecules of different kinds of different substance we call adhesion force. Water is known to have both the properties of cohesion and adhesion. Here the example of cohesion and adhesion. Cohesion, water drops stick to each other, and adhesion, water drops stick to other substance. So from these pictures, we can say when a matter comes into contact with a surface, both cohesion and adhesion force will act on it. Let's take a look at this video. Here are the droplets of water on leaves of terrains. If we can see, cohesion causes the formation of water drops, and adhesion causes the drops to cling to the leaf. From this example, we can define cohesion is the property of like molecules of the same substance to stick to each other due to mutual interaction, right? And from solid, liquid, and gas, the cohesion property in the case of solids is height, as a result of which they do not stick to the surface they are in contact with. For example, here are the droplets of mercury. Droplets of mercury will form perfect sphere because the cohesion of mercury is very strong. And adhesion, we can say adhesion is property of different molecules or a surface to cling to each other. All glues are very adhesive because they stick to other substances. So there are three conditions that might occur if we mix two kinds of substance. 1. If the cohesion force between particles of different substances is greater than adhesive force, the two substances will not mix. For example, coconut oil is mixed with water. 2. If the adhesion force between particles of different substances is equal to cohesion force, the two substances will mix evenly. For example, water is mixed with alcohol. But if the adhesion force between particles of different substances is greater than the cohesion force, the two substances will stick together. For example, water attached to the glass. Alright, the strength of the cohesion and adhesion force that act on the liquid is said to determine whether it will wet the surface or not. Here are the three effects of the cohesion and adhesion that can be seen in the daily life. 1. Surface tension. 2. Meniscus. 3. Capillary action. Now let's talk about the surface tension. Fill up the glass until the water reaches the top rim of the glass, and take a coin and very gently drop it in the middle of the glass. But wait, I will pause this video first. I have a question for you. Do you think if you drop the coin and not spill the drop? Watch. As you can see, water doesn't spill over the edges. How does this work? That's right, surface tension. Alright, in a cup of water contain many molecules of water, right? And as you know, each molecule of water is made up of one oxygen atom and two hydrogen atoms. Water molecules are attracted to each other and they hold on to each other with hydrogen bonds. The force that keeps them within close to each other is known as cohesion force. But cohesion and surface tension are not same. But cohesion is why the surface tension works. It can form hydrogen bonds with all its neighbors, and those forces pulling it to its neighbors are all balanced. But for water molecules on the surface, they can't form any hydrogen bonds with the air. So, they bond extra tightly to their water neighbors to the side and below. And they create a little pull downward, which allows the water on the cup to make such a dome, known as the surface tension. Surface tension is the result of cohesion forces between adjacent molecules, atau molekul yang berdekatan. Okay, from this example, we can say that's why the water glider can stand above the water surface. It because the result of surface tension also. Another activity, if we want to float a pin or a paper clip on the top of water. A pin more dense than water, right? But why it can sink? Because surface tension is strong enough to hold it up. From this example, we can see water does have really strong surface tension, right? But the strong surface tension can become weak if we mixing alcohol. Let's take a look at the video. Because these two liquids can mix together, mixing alcohol lowers the surface tension of water, and so does soap. Adding the detergent and soap can reduce the surface tension of a surface. Next, the second effect of the cohesive and adhesive is meniscus. The curved surface of a liquid inside a container is the meniscus. There are two types of meniscus: convex meniscus and concave meniscus. Convex meniscus, it's happen when the cohesive forces between the liquid molecules are greater than the adhesive forces between the liquids and the walls of the container. The surface of the liquid is convex. Let's take a look at mercury in the glass container. If we can see, the surface of the mercury is convex. Next, concave meniscus. It's happened when the cohesive forces between the liquid are less than the adhesive forces between the liquid and the container. The surface curves up Let's take a look at the water in a glass container. If we can see, the surface of the water is concave. But when both adhesive and cohesive forces are equal, the surface is horizontal. For example, distilled water in a silver vessel. Next, we talk about capillary action. Okay, let's take a look at the video first. If we dip one of the ends of the paper towel into the colored water and put the other end into the empty glass beside it, after a few hours, we can see the colored water transfer into the empty glass through the paper towel. Water travels uphill against the force of gravity. How is this possible? Yeah, capillary action. Capillary action is the result of cohesion and adhesion forces. When a liquid flows through a narrow space, the cohesion and adhesion forces act together to lift it against the natural force of gravity. Wetting a paper towel, water flowing up from the roots to the tip of a plant are a few examples of capillary action. There are another interesting in a capillary action. It's about the different height of water and mercury in capillary pipes. Let's take a look at the pictures. If we have two glass pipes with different diameters, and then we put them to each substance, which is water and mercury. Alright, from these pictures, we can say that 1. These two glass pipes act to lift the water. Why? Yeah, that's right. It's because the addition to the walls, the glass pipe, and the water molecules are bigger than the cohesion forces between the water molecules. We known as capillary action. The pipe with smaller diameter will have a greater height in a water level when submerged. So we can say the height of water risen in capillary pipes inversely to the diameter of the glass pipe. In a container filled mercury, two pipes don't act to lift the mercury because the addition to the walls, the glass pipe, and the mercury molecules are smaller than the cohesion forces between the mercury molecules. Alright, I think that's enough for today. I hope all of you understand all the concept between cohesion and adhesion. Thank you for your attention. God bless you.